identifying outliers by using interquartile range, namely IQR. Let's say we have a data set with numerical feature. Now let's take a feature and try to draw its probability density function to understand its distribution. Namely, this is a probability density function for a feature. Let's assume that. Now we are going to draw this kind of probability density function for a feature in the dataset. Okay, in order to do that, we need to follow following several steps. First, before plotting the probability density function, we need to normalize the feature so that its mean is 0 and its standard deviation is 1. This step ensures that numerical features with different scales can be compared fairly and consistently. This is very important step. In the second step, by using the normalized feature values, we will draw the histogram. Namely, a histogram provides a visual representation of the density distribution of the data. The probability density function curve is a smoothed version of the histogram that estimates the probability of different values occurring in the dataset. Namely, actually, this is the probability density function curve of the normalized data points. Actually, this curve is the smoothed version of the histogram that estimates the probability of different values occurring in the dataset, because we have here different values, and this is the density or probability of the different values here. Many machine learning models, such as linear regression and logistic regression, assume that the features are normally distributed. By examining the probability density function, we can determine whether our data follows a normal distribution or if it is a skewed one. In the probability density function, the horizontal axis, namely the x-axis, represents the normalized feature values. For example, this capital X, this is the value of the normalized feature values. Then the vertical axis represents the density, which is the probability per unit on the x-axis. Therefore, the total area on the curve sums to 1, ensuring that the distribution is valid. In other words, the total area under this probability distribution curve is always 1 or 100% because it represents the probability distribution of the entire feature or entire values. Any section of the curve represents the likelihood of data pointers falling within that range. What is the difference between a histogram and a probability density function? Actually, a histogram shows row counts or frequency of data, while a probability density function smooths the histogram into a continuous function. That is the difference. Therefore, drawing a probability density function for a numeric feature is important in order to know the distribution of the data. Here, why we talked about the probability distribution function? Because we are going to understand the interquartile range. Actually, the interquartile range defined based on the probability density function of a feature. Now let's see it. In order to calculate the interquartile range, the feature, namely this probability density function, divided into quartiles, denoted as Q1, the lower quartile, this is the lower quartile, Q2, the median, for example, this is the Q2, and Q3, the upper quartile. This is the borderline of the lower quartile, corresponds to the 25 percentile. Namely, this Q line is located in the 25th percentile of the whole probability density function. Namely, from beginning to this Q line, this data amount occupies the 25% of the data in the case of normal distribution. Then the upper quartile, Q3, namely from here, actually from here, 75% to the 100% also occupies 25% of the whole data. Therefore, the definition of the interquartile range is, namely, this area. Therefore, the interquartile, namely IQR, represents the middle 50% of the data. I repeat again, this is the first quartile, and this is the third quartile, Q3, and this is the second quartile or medium quartile, middle 50%. Let's see it. This interquartile is a measure of statistical dispersion, which describes the spread of data. It is also known as mid-spread, or sometimes we call it middle 50%, or sometimes we call it fourth spread, and sometimes also we call it eighth spread. But I would like to prefer middle 50% because it's located in the middle and it occupies 50% of the whole data. Therefore, I call it middle 50%. The IQR is defined as the difference between the 75% and the 24% difference. Namely, IQR is equal to Q3 minus Q1. In other words, from here to this line, namely the 75% line occupies 75% of the data, and then from here to here occupies 25% of data. Therefore, the difference is the IQR, or middle 50%. Therefore, IQR is equal to Q3 minus Q1. Namely, this is in terms of data amount. If so, how we identify outliers? By using this interquartile range. For this, we need to use 1.5 rule. Namely, there is a rule, 1.5 rule. Namely, 1.5 multiplied by IQR. Then we get a number. Therefore, that number should be minus from this Q1. And then that number should be added to Q3. At that time, we get a range. For example, in this side, we get this range from here to here. In the lower part, we get the range from here to here, actually. Therefore, we call this lower bound, and then we call this line is upper bound. Namely, based on this 1.5 rule, we get two bounds, lower border and upper border. Therefore, outliers are typically defined as data points that follows below this and above this region. Namely, this red area and this red area, they represent only 0.35% in the upper region and 0.35% in the lower region. Actually, these two regions are equal to the outliers value. And this is the data we are going to use in the machine learning. And actually, this is the data we should remove. And this is the data we should remove as well. For example, in the fraud detection, unusually high purchase can be flagged as potential fraudulent activities. They all falls in this range. For example, in a sensor readings, value outside the IQR bounds, this area and this area may indicate sensor malfunctions. Therefore, this is the interquartile range, how we define. Namely, we are going to define a threshold. If we have a data set and we have data features, numerical features at that time, by using this IQR, this method, we can define this kind of lower bound and this kind of upper bound region. This is for theoretical because this is normal distribution. In the case of perfect normal distribution, this bound is just like this, namely 0.35%, 0.35%. But in real world scenarios, this might be different. This location might be different. At that time, this might be changed. This might be changed. But we can get it by using this kind of rule. Therefore, we can calculate that bound. Therefore, this is very convenient. I repeat again, please note that this value, namely this 0.35, this value is only for perfect this kind of normal distribution. In the real world, we might have normal distribution, we might have some kind of skewed distribution. Therefore, this value might be changed to some extent, but we can get it using this kind of interquartile range calculation. Therefore, using this method, we can define this kind of threshold. That's the purpose of this section. By using this outlier region, this value, where we can remove the outliers value from the dataset. That's the purpose. Now let's move to the coding session and see an example of identifying outliers using IQR. To save time, I have already prepared the code using the house price dataset, which we used in the previous section to identify outliers in the price feature. This ensures consistency as we analyze the same dataset. Now, let's apply IQR to detect the outliers. First, I will copy the code and paste it here, then explain the code line by line. Now, let's do that. Paste it here. This is the code I just prepared. First, let's see the code line by line. In the first step, I just imported some necessary libraries. I imported pandas, imported numpy, and I just imported ipython.display. In the second step, I just created a dictionary. Namely, I just used the previous example. We remember that we have three features. The first one is square footage. These are the values. The second one is bedrooms. These are the values. The final one is price. These are the values. Therefore, I just created this data dictionary. By using this data dictionary and by using the pandas data frame functionality, I just created this data frame. Okay, then I just extract the price as a variable. Actually, I am going to identify outliers in the house price. Therefore, I just extract the house price from the data frame. This is the house price actually. Okay, then by using numpy's percentile functionality, I am creating the lower quartile and I also created the upper quartile, because the lower quartile, we just explained that it's the first 25%. Then the upper quartile or the third quartile is about the 75% quartile. Therefore, the Q1 we just calculated like this, then Q3 we just calculated like this. This is based on the probability function. We just see that in the above. Okay, therefore now we have data frame, we have our price, this feature, then we have the Q1, namely lower quartile, then we have the Q3, namely the upper quartile. Okay, now let's calculate the IQR. Namely, based on the definition above, we just mentioned that the IQR is equal to Q3 minus Q1. We saw that in the previous section. This is very straightforward based on the explanation about the probability density function above and the relationship between the IQR and the probability density function. Okay, then in the step 5, we determine outliers as data points that falls outside the 1.5 times the IQR on either side of the data distribution in the probability density function curve. Namely, the data points that falls below the lower range or above the upper range are considered outliers. Namely, in the previous section, we defined the lower bound and we also defined the upper bound by using this 1.5 rule. Okay, then the outlier is, therefore, because we have lower bound and now we have upper bound, therefore, we need to calculate the red area in the probability density function. Previously, we just seen that. Okay, therefore, the outlier is, namely, we have the price, this feature, and the lower than this lower bound, larger than this upper bound. Namely, the outlier is located in the two regions. One is less than this lower bound, and another one is larger than this upper bound. Therefore, two red areas in the probability density function previously we have seen in the previous section. Okay, finally, I just displayed the outliers. Now, let's run the code and see the result. Whether we can differentiate, whether we can identify these two outliers, because we know that in the previous section we have identified outliers from this dataset. Namely, one is in the price, $1,500,000. The second outlier is only $10,000. Therefore, let's see using this IQR method, whether we can differentiate, whether we can identify these two outliers in the dataset. Okay, now let me run this and see the result. It's working great. Namely, we have extracted, namely, we have identified this 1,500,000, and then we also identified $10,000. Therefore, this works great. Actually, here we didn't define a threshold. We just follow the rule based on the 1.5 rule in the IQR, and then therefore it's automatically defined the lower bound and the upper bound. Therefore, this method is very reliable, and this method has the mathematical and statistical base. Therefore, if you have a large data set or if you have a small data set, in any case, we can use this IQR method. Namely, by using this IQR, we can detect outliers. This is very good, and this is very reliable method. Let me explain once again. First, imported the libraries, then create the example data, and then just create the lower and the upper quartile, then define the IQR based on the quartiles, then we just define the lower bound and the upper bound. Finally, based on the lower and the upper bound, we just define the outliers. Therefore, finally we display it. This is the result. Okay, this works great. Now, this is the lower bound and this is the upper bound. Therefore, this is the region free of outliers. Now, let's summarize this session. First, outliers are typically defined as data points that fall below this lower bound line and above this upper bound line. The IQR gives a clear picture of the data variabilities by focus on the middle 50%, excluding the influence of the extreme values. This is very clear. Then, unlike the range or standard deviation, the IQR is not influenced by the extreme values, making it a robust measure of spread. IQR is an essential component of boxplot, namely a graphical representation of data distributions. It highlights the essential tendency and variability in data. IQR can be used to compare the variability of two or more groups without being influenced by the extreme values. In machine learning preprocessing, trimming outliers based on the IQR threshold can improve the model performance by eliminating noisy data points. This is very important. Namely, in machine learning preprocessing, we need to remove the outliers. If we remove the outliers based on the IQR threshold, it can be improve the model performance and eliminating the noise data points as well. Finally, IQR is often used to pre-process data by removing or transforming outliers, ensuring the data is clean for analysis or modeling.